Now we're going to be putting in linear equations and quadratic. So we're going to do systems of linear and quadratic. Yes. Yes. Okay, so we need to figure out what that would look like. Just put it here. So on this page, draw this for me. When we're solving quadratics and solving a system of linear and quadratic, we have three options as a solution. We can have a parabola. So just graph a parabola. And a line that intersect, like this. Remember, whenever you're dealing with a system, the solution is where they intersect. So you can have two solutions. Okay, you can have a parabola that kind of looks like this. And a line that intersect like this. In just one spot, they intersect in just one spot. So one solution. Let's draw the pretty pictures, please. Or we could have a parabola and a line. That never intersect. So this would be no solution. Any questions over that? Okay, this is very similar to your linear systems of equations where you found where the two lines intersected, or sometimes they were parallel lines so they would never intersect. Sometimes you also had the same line where they overlapped each other. Does that remember? And it was all real numbers were the solutions because it was the same exact line. This case, you can't have the same thing because you're having one that's linear and one that's quadratic, and they're never going to be the same. Okay, so your options are two solutions, one solutions, or no solutions. Does that make sense? We're good? Okay. Okay, so it asks us, how many solutions does the systems of equations at the right have? Explain. So I'm just going to use Desmos to show this. So I'm going to be right here. And I'm plugging in y, oopsie, equals x squared. So that's the parabola. And then y equals just x, the linear equation. And how many solutions does that have? 2. It even tells me what my solutions are. 0, 0, and 1, 1. Okay. So that's what I'm going to write here. How many solutions does the systems of equations have? There are 2 solutions because their graphs intersect in 2 points. Not in, at 2 points. Okay, so we're going to graph this just to get a visual from what our desmos was. The parabola went through 0, 0. The line intersected kind of like this at 0, 0 and at 1, 0. Sorry, not 1, 0, at 1, 1. Any questions over that? We're all good? Okay, so let's try the next one. What are the solutions to each of the equations? Rewrite each as a systems of equations and graph to solve. So here's a quadratic function. They want you to write it as 2 equations. So I'm going to show you how to do that. The first equation will be that one side of the equation. So we're going to have f of x equal just x squared plus 1. And we're going to have g of x equal x plus 3. Any questions over that? We're good? Okay, one's linear, one's quadratic. So we need to review how to graph both of those. Okay. So this is in vertex form of a quadratic, which is a times x minus h squared plus k. And your vertex is hk. Can anyone give me my vertex here? Yeah? Very good. Since there's no parentheses squared here in this equation, the h value is 0. The k is the number being added to the squared thing. Here's my squared thing. So the k value is 1. So that's your vertex. So we're going to graph that. Since my vertex is above the x-axis, I'm going to move my x-axis lower. So I'm going to graph where x is 0 and y is 1, which is right here. Then we need our a value. Can someone tell me my a value in this equation? 1. Very good. Okay, remember the a value is the number in front of the x squared or the parentheses squared. So right here in front is a 1, so a is 1. Does anyone know my pattern rate of change for parabolas? Yes, Aiden. Yes. A over 1, then 3a over 1, then 5a over 1. That's our pattern, 1, 3, 5. Okay. So it's 1 over 1, then 3 times 1 over 1, then 5 times 1 over 1. We want to make sure we graph very accurate. When you're solving a systems by graphing, you need to make it very accurate. So go up 1 over 1, up 1 over 1, up 1, 2, 3 and over 1, 1, 2, 3 and over 1. Okay, and try your darndest to make this nice and pretty. Okay, so that is our quadratic function. Now let's look at the linear side. Okay, let's review linear equations. Linear is y equals mx plus b. Okay, Monique, what is my m value, my slope for the equation they gave me? It's the number in front of the x. What number is in front of the x? Not 0, 1. And remember, slope is always a fraction. It's rise over run. Okay, so I rise 1, so I go up 1. And then because it's a positive, I go to the right 1. That's how I'll move. Okay, Lily, what is my y-intercept, the b value? 3. Oopsie. So b equals 3. Okay, so you're going to graph 3 on the y-axis. Does that make sense? So I'm going to go where y is 3, 1, 2, 3. And then I rise, I go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1. And this is my line. Okay, the solutions here are where they intersect, which is right here and right here. They are an ordered pair. So my points are my solutions are 2 and 1, 2, 3, 4, 5, 2 and 5. And then 2 or negative 1. Negative 1 for x and 2 for y. Any questions over that? We're all good? Okay, so that's how you would solve by graphing. Okay, now we're going to go over here. We're not going to solve by elimination. We're going to solve by substitution. Okay, when you substitute, you're going to replace them with equal. So since this is always already y equals, we can just set them equal to each other. So that's going to give me negative x plus 4 is equal to x squared minus 2. I'm just substituting this in for the y. Because I already know what y equals. Y equals negative x plus 4. So I'm replacing the y with negative x plus 4. Okay, now this is a quadratic. Okay, the first step in solving a quadratic is set it equal to 0. Okay, so I'm going to move this x and move this 4 to the other side, so it's 0 on that side. Any questions over that? So we have 0 here. Are x squared and x like terms? No, not the same. They are the same variable, but they don't have the same exponent, so they're not like terms. So you just get x squared plus an x. Are negative 2 and negative 4 like terms? Yeah, they're both numbers. Negative 2, negative 4 becomes negative 6. Any questions over that? Okay, once we have them equal to each other, now we're going to solve. So we have to factor. This gives me x squared, x, and negative 6. Okay, Brandon, what are my factors? Okay, so this will give me 3x. This will give me 2x. Okay, I want the middle term to be a positive number. So which one needs to be negative and which needs to be positive? The 2 needs to be negative, and the 3 needs to be positive. Okay, so my next step now is to separate my factors and set them equal to 0 and solve. So I have x minus 2 equaling 0, and I have x plus 3 equaling 0. I add 2 to both sides, and I get x equals 2. I subtract 3 from both sides, and I get x equals negative 3. Okay, those are my x values. I'm looking for an ordered pair because I want to see where they intersect, right? So I need to plug it in to find the y value. Okay, now remember you did this last year. You're going back to your original 2 equations. It doesn't matter which one you plug it into. Okay, if you've solved correctly, then they should both work. So you're going to take this and plug it in. I'm going to choose the top equation because it's less work. Smaller numbers, I don't have to square anything. Okay. So I'm going to get y equals negative. I'm going to plug in 2. And then plus 4. So I'm going to get y equals 2. So one of my answers is when x is 2, y is 4. That's one place that they intersect at. We do the same thing with the negative 3. So y equals negative, oopsie, negative 3. Yes. Okay. So minus a negative 3 makes that a positive 3. Yes. So when you're solving, right here, we have x is minus 2 equals 0. I have to add 2 to both sides. So that's why my 2 is positive. X plus 3. So this becomes y equals 7. So my ordered pair here is negative 3 and 7. So those are my 2 solutions. Any questions over that? We're okay? Okay, next one. Okay, I know that this is a lot of work. Yes. This equation. I plugged into this equation. So negative x plus 4. I'm sorry? Oh, that 4. Oh, yes, it is a 2 and a 2. I don't know why I put 4 there. Thank you. This is my 2. Yes, so 2 and 2. Fix that, you guys. Good job. I was just looking at the 4 above it for some reason. Any questions over that? We're good? Okay, next one. Same idea. We're going to follow those same steps. I have a quadratic, and it's equal to y. Okay, so I'm just going to take this equation and substitute it in for y. So I have negative x squared plus 4x plus 2 is equal to 2 minus x. That first step, again, is to set it equal to 0. So I'm going to move this 2 over and this x over. So I get negative x squared. 4 plus 1 is 5x. And 2 minus 2 is 0. And it equals 0 on this side. Any questions over that? Okay, there's only 2 terms, and they both have an x. When both terms have an x, then you have to factor by grouping. Or find the GCF. Not factor by grouping, but find the GCF. Okay, they can both be divided by x, but your first term is negative, so you're going to pull out a negative x. That's going to give me a negative divided by a negative, makes that positive x. And 5x divided by a negative x is a negative 5. So my factors are negative x times x minus 5, and it equals 0. Any questions over that? Okay, next step after we factored is to separate your factors and set them equal to 0. So negative x equals 0, and x minus 5 equaling 0. So here you divide by negative 1. Doesn't matter because 0 is unaffected by negative, dividing by negatives. It's just 0. Here I add 5 to both sides, and I get x equals 5. Last step is to plug it in. Okay, I'm going to plug both those into one of the equations. It doesn't matter which one. I think the bottom one is easier to deal with, so I'm going to use that. If you choose the top one, it'll still work, just more work. So I have y equals 2 minus 0. So y equals 2. So when x is 0, y is 2. Next one, I have y equals 2 minus 5. So y equals negative 3. So when x is 5, y is negative 3. Any questions over that? How are we doing? Okay, we're going to go to the next page. Okay, I'm going to have you guys do number 10.